my presentation with the topic Systematic Evaluation of Wheat Flour, Starch and Protein in Urea and Phenol Formaldehyde Resins. Additives are used in the wood-based panel industry to modify adhesives in various ways. They can be used to prevent the resin from penetrating into the wood surface, adjusting the batch viscosity, extending the open time, reducing costs or improving contact of adhesives. The addition can also have a positive effect on the adhesive in the polymerized state. For example, the adhesive bond is softened and thus the processability improved. The adhesive strength can be increased or joint filling properties achieved. Additives can be divided into extenders and fillers. Extenders are described as having adhesive property, inert, non-volatile, liquid or solid components of an adhesive that serve to reduce the consumption of the adhesive bases and thus costs. Fillers, in contrast, are defined as non-volatile, rather inert, non-adhesive solids that are insoluble in the adhesive and are added to modify strength, durability, processing properties, or other characteristics. However, the distinction between fillers and extenders is blurred, and clear attributions are difficult. One of the most common extenders used in plywood production is wheat flour, but the addition is mainly based on operational experience. Therefore, the aim of this work was to systematically analyze the addition of up to 100% wheat flour, maintaining a constant solid content, to the plywood resins, urea and phenol formaldehyde. Wheat flour consists approximately of 67 to 70% starch and 12 to 18% protein. To have a better understanding of the effects of the single components of the wheat flour, the main components were investigated as well. The influence on the resin properties, the curing behavior, and performance of the adhesives in plywood were investigated, and some results are shown here. Here are some of the findings that are presented briefly. The change in viscosity of the adhesive mixtures was measured for different amounts of extender addition for UF and PF resins. Viscosity is relevant for the adhesive application and penetration and thus influences the quality of the bond line. It was quite obvious that the addition of protein and wheat flour increased the viscosity of the resins, even though the solid content was kept constant. Wheat starch did only show a small increase in viscosity for UF resins and even a decrease for PF resins. The protein addition was limited by its high effect on the viscosity. Protein had the highest effect on viscosity. 9-layered birch plywood boards were produced with the various extenders at different amounts. Wet tensile shear strength was tested according to EN 314-1, where the UF boards were stored for 24 hours in water and room temperature, which are the requirements for Class 1 interior use. The PF boards were boiled for 72 hours, which are the requirements for Class 3 non-covered exterior use. The tensile shear strength and wood failure percentage were evaluated according to EN 314-2. To fulfill the requirements according to the standard, the tensile shear strength needs to be over 1 Newton per square millimeter, which is indicated by the red dotted line here. When looking at the results for the UF-based boards, the requirements are fulfilled by adding wheat flour, wheat starch and wheat protein at every amount. For PF-based boards, the requirements of the standard are met by adding up to 10% wheat flour and starch and 30% wheat protein. The protein addition was limited by its viscosity. To conclude my presentation, it was found that the addition of protein is limited due to the resulting high viscosity. The protein content in the flour is responsible for the sharp increase in viscosity. Up to 100% wheat flour and wheat starch can be added to UF resin and fulfill the requirements of Class 1 interior use. Protein addition is limited by its high viscosity. It was possible to save half of the UF resin by adding the extender wheat flour and starch and still achieve the required wet bonding strength. With an addition of 10% wheat flour and starch and 30% wheat protein to PF resins, the requirements of Class 3 non-covered exterior use are fulfilled. The protein content in the floor is important because the wet bonding strength is maintained by partially replacing of PF with protein. Thank you very much for your attention.